Okay, so good afternoon, everyone. Welcome to COM 2160. I think you guys are doing okay so far. So, can you see the slide and hear my sound? Everything is okay? Can anyone just confirm me? Okay, so your assignment 3 is done. Hopefully, everyone submitted it. And then I will upload assignment 4 today for sure. I tried to upload before class, but I couldn't finish managing it fully. So I will upload it soon. You don't have any more lab, and we have like kind of like these very last topics of our course. One is like how we can include exception like class type behavior in C, also like exception handling in C, and then we'll just go through one case study at last. Okay, so any questions so far before we start? Okay, so let's start then. The final exam is online, yes. So it will be either on CrowdMark or your YouLearn. Okay, I'll let you know. So what I will do, like for our topics of this course, I will finish it by Friday. Okay, and then I'll just go for the review for the we have like next week we have just one class, Monday class. So I'll just review like the things, the questions review for the final exam, or like total topic of your final exam things. Okay, clear how it will be, or structured kind of things. Clear? Okay, so let's start. So last class, what we did, memory fragmentation, right? How we can do memory defragmentation, right? And then we used the concept called double buffering, right? So we kind of not implemented, we just look at the interface and the main file for how we can do it, the defragmentation algorithm in C, right? And then we just described like what is inheritance and polymorphism, right? Okay, so this class will start from there, like we will define a new concept called union and how we can use this concept in C. And then also this is a new concept, function pointer. Actually not new, if you can remember, in our very first lab we have a function called qshort, and there actually you didn't use it, you just applied it, like you didn't get the flavor, you just run the code, right? And there was a function pointer actually. Okay, and then we're going to implement the inheritance like and the polymorphism like behavior in C. And then at last, if we have time, we will go for the exception handling. We will list the strategies for detecting and the handling errors, and also like how we can compare and contrast the strategies for detecting and handling errors. Okay, so let me clarify one thing, is that in my last lecture I said that the buffer is kind of an array of linked list or something like that, but the thing is that the buffer and you have the linked list, those are two different things. So this is the buffer, it's just an array, nothing else, and you have the linked list as a structure kind of. Okay, this is the structure, this is the members, these are the members of the structure. Okay, and this buffer is just an array, nothing else, it's just any space. Okay, it's just, okay, is it clear? So those are not two same things, those are different things. Okay, clear? So I just want to clarify these things, and then we're going to start from union. Okay, so what is union? Basically, by union we're going to simulate polymorphism in C. Looks a lot like the structure because it's the same kind of same way we can like define the structure, right? So now we have to use a different keyword called union. Then this is the name, okay, and then these are the members. Okay, Also we can have this type def things like structure, like we can say type def union and then the name, and we give it short name or any other name. Okay, so what is the difference between structure and union then? These are the two difference actually. This is the main difference actually. Like only one property we can use at a time. So if I have this double and integer, I cannot use these two at the same time. Okay, if I use double, I cannot. So using this instance, if I use double, I cannot use integer anymore. Okay, so what is the reason behind that? Because the size of the union, okay, only takes the widest type. So what is the the size of double? Can anyone answer? What is the size of double? 8 byte, not bit actually, byte, right? What is the size of integer? If you have 64-bit machine, maybe it's, yeah. So double is 8 byte, right? And integer is 4 byte, right? So you know that the widest type means whatever the largest is. So actually it will just take 8 byte, not like you will just add 8 plus 4, it will be 14, like a 12 byte, not like that. Okay, so it will be in together 8 byte for union. So that's why we cannot use the both property at the same time, because they are going to share each other. How? We can see one figure. Okay, so before that I just want to let you know or recap the things like what is polymorphism, right? Okay, so suppose if you think about a person, he can be a man, at the same time he can be father or husband or employee, right? So same thing, suppose if you can remember the Java polymorphism, you have the same function name, same argument, right? But that same function can be worked like in many forms, right? Depending upon like which child class it is using, right? Okay, so polymorphism allows us to perform a single action in different ways. In other words, it allows you to define one interface, right, and have multiple implementation. Same thing, but depending upon who is inheriting this parent class, right, and how it's defined there, right? So this is the thing I just said before, right? So this is the difference between the union and structure, right? So I also uploaded a code in your EMLearn. We can also look at there. So this is the code actually, right? So what we're doing here, we are declaring a union at first, right? And then we are declaring a structure, right? And then in the main function, this is just instance, right? Okay, so now who can tell me like whatever I will print here, this one, like how many byte I will get? So Adrian asks, structure union both uses the malloc, right? Yes, though that part is different. Like you can use dynamic allocation, that is okay. Yeah, so what is the size of this union? Like I already told you the answer, right? 8 bytes for the union for sure. And what is the size for this structure? Yes, 12. Okay, clear. So now let me tell you one thing. So what I am doing here, I am saying this instance u dot x equal to 42, right? Okay, so I said that we can just access one at a time, right? So this thing actually it will not work. It will not give you an error or warning, but it will not actually work. So whenever you will print this, you will you will get like, you know, that this 42.0 rather than getting 42.0, you are getting some 42.000, then some number maybe for this guy. Okay, because they are just sharing the space. Is it clear? You can just run it and have a look after the class. Okay, so this is the main thing I want to focus. That is, whenever you are declaring the structure, right? So this is for integer, right? And this is for double, right? So those memory allocations are different, right? But for union, actually they are sharing the space. Okay, this is integer and this is the double things. So they are sharing the space. So that's why just you can use one member at a time. Okay, clear? Any questions so far? Okay, so now we are going to shift for polymorphism in C. So if the union, so one question, if the union has a double and two integers, can we still only use one integer? Yes, you can do that. The thing is that whatever you will just assign the very first thing that will use. Okay. So the thing is that suppose you have integer d, integer e, right? So suppose you are creating the instance and you are saying that that instance dot d equal to something, right? So whatever you will declare first, right, or assign first, that one you can use only. Is it clear? Okay. Why union share the space? Is there any purpose of it? It's actually the design things like another thing you can assume that for union we are using like the polymorphism in C, right? So whenever you are using the polymorphism things, like we will see one example, that is maybe we have different kind of members, but we just need to use one at a time. Okay, we will see one example. Clear? So how we can simulate the polymorphism, right? So what is polymorphism? We already described. So this thing, actually we know that it's not available in C, right? The polymorphism things. Uh, so it's kind of awkward, like how we are going to design it. Okay. So for this, actually, we know that I'm not going to ask any question in final regarding this like polymorphism, like applying or coding polymorphism in C, rather than kind of I can just ask the concept, like maybe a function pointer things. Okay, because like this polymorphism things is not the part of the C programming language, right? We're kind of doing it like we're kind of bypassing the things, right? Okay, so let's look at shifts.c. Actually I already uploaded those two code, like there are two codes I uploaded. One is shape1.c and another is shape2.c. So we'll go for shape1.c at first. Okay, so what we're doing here, so this is the very common example for the polymorphism things, right? So you already maybe you already know like how we can implement just shape, and then we have different kind of shape, just inherit that, right? So we can just declare rectangle at first, right? So this may be new to you, that is we are using a library called stdint.hy. Then we can use like the unsigned integer. We can also mention how many bits it will use, or by yes, so this is 1 byte actually. Okay, so we are saying that unsigned integer 8 underscore t. So this is the way you can declare, or this is the data type for if you need like the unsigned integer 8 bits. Clear? Okay, so for rectangle we know that we need width and height, right? So we just declare a structure like that. For triangle, okay, we need the base and the height. We just declare a structure like that. Clear? Then for circle, it's just pi r square, right? So we just need the radius, right? Okay, and then we are declare. So maybe I will come this part later. Okay, so what we're going to do now, we're going to uh, make some function, right? Okay, so at first we are just declaring a union, right? We name it dimension, right? Okay, so now what inside this union, what are the members? We can just have the structure rectangle, structure triangle, and structure circle. So now maybe you can know like why we are using union here, right? So you know that whenever we are using union, it's just like you can use any of the member, right? And it should be clear to you now that whenever we are a child class is inherit the parent class, or we are just you like using any kind of shape, right? Is just like we are just using either rectangle or triangle or circle. We are not using these things together, right? So now is it clear like why we're doing this, why we're sharing the space? Adrian asked that question. So in this union, right? Okay, so this is like we have rectangle, we have triangle, we have circle, but we are not going to use like together. We are just using a single shape at a time. That's why like we can just do a union things. Okay, clear? Is there any way to tell which member is selected? Yes, we will see that. Yeah, it's just like instance of in Java, right? Okay, we'll see. We can do that using function pointer. Okay, so function pointer is cool. Yes. Okay, so now in this line number 28, what we're doing, we're just using instance or the short form shape, right? Okay, so now we are having another structure. Okay, and we are just in that structure, we just have declare a member of the instance of the union. Clear? Okay, so now we are just initializing it or kind of constructed things. This make rectangle, this make circle. Clear? We are uh, we are not doing the triangle things, but it will be same as well. Okay, so this make rectangle, this is a function, right? It takes two argument, one is width and there is height. Those are also like unsigned integer 8-bit. Okay, so this is a new thing to you also. Clear? Whenever we are this is called the curly brace notation or something. Whenever we are doing like some you know that this is the instance of rectangle, right? Rectangle structure. So this is another way of assigning the values. We are saying that equal to, and then we have these curly braces, right? So whenever we have these curly braces, so we can write like this. So what is the member of the rectangle? One is W, another is H, right? We can say that dot W equal to this W, okay, and a comma sign. Dot H equal to this H. Okay, so we have another short form. Rather than using this, we can also write this W and H, W comma H, but this is better. We are sure that we are assigning the right thing to the right parameter. Okay, so now we are just declaring another instance of the shape. We are just naming it R. Okay, so shape contains only one member, that is dim. Okay, and then we just pass this guy. just declaring the things, we're just passing or assigning. This is kind of a constructor things, right? And then we are just return this R here. Clear? Any questions so far? Same way for make circle. Okay, so we are creating instance of the circle first. Whatever the value we passed, we just assign there, and then create another instance of the shape. Okay, so in the shape we only know that there is a dimension there or dim, so we are just assigning that value, return that parameter. Clear? Okay, so let's see like how these things is working. So at first we are just initializing our rectangle. We're giving the value 2 and 3, and then we're initializing our circle. Okay, yeah, so we are not doing anything about the triangle. We're just doing rectangle and circle. Okay, so then what we can do, so whenever you are just creating instance or initializing things, right, then we can just use array, right? So and then we can just have different kind of shape in each of the array index, right? Okay, and then we can get the dimension like this, right? But what if like what we are going to do then? The problem is here. So whenever you think about the polymorphism or inheritance in Java, you have the methods, right? So that methods actually you know that you have different implementation in each of the child class, right? But we don't have any method in our structure or union, right? How we can do that, right? So we are going to give up or not? Okay, so that's the question, right? So what we are going to do, we'll see. So union only gets us so far, right? We have got the polymorphic data kind of, but there is still no behavior attached to my data, right? So how we can do this polymorphism in C programming language, right? So that's the question. And now we have a new concept called function pointers. Okay, so this is actually kind of a pointer that referring to the function. Okay, a variable containing an address. Clear? So how we can declare this? So the thing is that our code exists in memory for sure, right? So we can point our code using a variable, right? So that is actually the main concept of using a variable that will point to a function. Okay, so you know that in our structure or union we don't have any methods or behavior, right? But what we can do, we can just declare a variable, right? And that variable can point to another function. That's actually main thing. Okay, we are doing use or we are using the function pointer. Okay, clear? So kind of we are invoking the pointer. A function pointer is a variable. This is a variable, right? Contains the address of a function. So we are using that variable inside our structure union, right? And that variable actually points to a function. So this is the way we can use kind of behavior inside our union, right? Okay, so this is kind of a awkward also. So the function takes a char and returns a char. So how we can do, so we can just declare a function like this, right? So this function 1 takes a char value and then return a char value, right? And now, so how we can declare a pointer to this function? The rule of declaring a function pointer is you have to mention at first what is the return type. So the return type is char, right? And then the name of the function using the pointer sign, and you have to give this parenthesis. Clear? And then whatever the argument it takes. So this is a function prototype, right? So from this function, if you want to create a function pointer of this function, at first you have to say the return type, then name the pointer any name or a meaningful name using the pointer sign and this parenthesis. Okay, and then what is the argument it takes, the type and the name. So Matthew asks, do you need to have the name of the variable in the pointer declaration? Yes, you have to. Name of the so this is if this is a, you know that if this is a function prototype you don't need, but this is kind of a like it's optional, right? But if you put it, there is no harm. It's recommended that you are not going to have anything like that, just data type is enough. But for this example, like the function pointer example, right? So actually what you are going to do, you are just keeping all the things same, except you are just adding this portion. Clear, Matthew? Okay, so let's look at another example. The function takes a pointer to chair and returns a pointer to chair. Suppose this is the function, right? Takes a pointer, chair pointer, right? Also return a chair pointer, right? And the name of the function is function2, right? Okay, so how we can declare a function pointer of this function? Okay, same thing, like the return type should be same, right? Then the name, a meaningful name with the pointer and the parenthesis, and then the argument would be same here. Okay, so how we can initialize a function pointer? We have to assign the name of the function to the pointer, nothing else. So we know that this was our first function pointer, right? So that was just declaration, right? Okay, so now we are assigning like which one it will point. Clear? Now we are just assigning. Clear? Or initializing. So one is declaration and another is initialization. So the previous things was just declaration and this is the assignment. Okay, clear? So you have to remember that we don't have any parentheses here. Okay, and the values are actually populated in the linking stage. Like if you can remember, we had 4 stages. Like in the linker stage, it's done its work, and then when calling the function, it is the same way. I will describe. So actually, we are invoking the pointer the same way we are invoking the function. Okay, so yeah, so this is the way. So what we are doing here, we are just calling, right? Okay, we are just calling that pointer. Okay, clear? Any other questions so far? So you know that this is the first one was just character, so it was like that. The second one was character, like the string character pointer, so the string, so just like that. Clear? So now we can look at the function of our shape structure here. So now what we're doing here, this was the previous member, right? Okay, so now so normally what we are going to do in the shape example of inheritance or polymorphism things, right? For sure we are going to use a print function, right? So that it's done differently in various child class, right? Maybe an area function, right? So print area, and then Matthew asked that what about like if we get like what kind of instance is this? We can use a type function, right? So let me explain one by one. So for print, okay, so what we are doing, we are taking what kind of shape it is, okay, and then like where we are going to print, okay, we can go for std out even. Clear? So our print function is, so we are not assigning here, is just declaration, right? So the name of the function pointer is print, right? Okay, and what kind of function we can use here, just give me one example. That is, suppose here, right, we're printing the rectangle, we're printing the circle, right? So for that we are just using what kind of shape it is, and for file pointer it means that where we are going to print. Okay, so maybe we can give for standard output, it will print on the screen, or maybe file if you want to choose. So then this is our definition of this print rectangle function. Okay, so you can use fprintf. The first one is like where it's going to print, and then what it's going to print, right? So whenever we have this shape, we can access like this, right? Clear? One is the width and there is the height. Okay, so we'll see like where we are going to assign that. And then we have the area function pointer, right, for calculating the area, right? So suppose an example can be like this. Okay, so it's returning a double value, right? And what we're doing here, we are just calculating the area of the rectangle, right? So we are saying like this, okay, or for the circle is just like this, right? Okay, so this is the pi. You can use math.h to get the value of the pi, okay, and then you are just doing r square. Clear? So now we have another one called type. Okay, so for that actually we are going to use this function. So Tahmid asked, is there a difference between declaring and initializing? Yes. So suppose whenever you say integer d, that's declaration. Whenever you say integer d, or maybe in the next line if you say d equal to 2, then that's initialization, right? Is it clear? Or you can do it together in like if you don't use, so here we are not doing it together, right? So because is we are just having this function pointer, we don't know like where we are going to like in which case we are going to use it, right? It can be different for rectangle or like the circle, it can be different, right? We are not going to initialize it, right? Is there any so Matthew, is there any reason for the shape parameter in the type function? Is there any reason for the shape parameter in the type functions? Uh, can you elaborate your question? What do you mean by that? Shape parameter like this. Well, you have shape, yes, but I don't use it, so you are using this for type rectangle. Okay. Oh, I got it. Yeah. So, uh, yes. So what we're doing actually, we're passing here, right? And then we are not using it. Yes, you are right. Uh, we'll see. Okay, I will give you one example. Okay, clear? So now we are having these things like these functions, right? Okay, so now what we're doing here, so previously we have the make rectangle, right? So this is already the previous thing. So now whenever we are having this initialization of the shape, right? So previously we just had this, right? So now we are adding these three. Clear? So we are saying that dot print, that's a variable now, right? Because function pointer is a variable, right? So this is the assignment part, right, of the function pointer. So whenever we're saying dot print of this make rectangle, right, or shape R of inside this make rectangle, we are just calling print rectangle, right? Okay, so same like this, we are saying area rectangle, right? We are saying type rectangle, right? So maybe for that we don't need any kind of argument, we can keep it null. Okay, because we are not using that, it's just a typo. Okay, Matthew, because we are just kind of using a particular function, and by the function we can just return this kind of like what kind of instance that is, right? So we don't need this actually here. So this is about the make rectangle, right? What about the make circle? Same way we are designing, right? So this was the previous things, now we are adding this variable. These are the function pointer, now we are assigning to particular function, right? For print, print circle, for area, area circle, for type, type circle, right? Clear? So now if you look at this example, so now what we are going to do, so for now, for previously we had nothing inside the for loop, right? We just declared, and then inside for loop we cannot do anything because we didn't have any behavior. So but now we can easily do like this, right? We can say that for like we can use the for loop, right? And we can just say like this, what kind of at first, right? And what is the area, right? Here. So this is actually we are kind of invoking or kind of trying to do things like what we do for inheritance in Java or Python, but still it's not the exact way we are doing. Like if you compare with the Java, we use kind of extend keyword, like there are abstract keyword. We cannot do like that, right? It's just like if there is any way you can get the flavor of those kind of things. So it's not user friendly, I will say. I say like it's awkward, right? So that's why like I will not ask anything or any question like how we can like design the inheritance in C type question. No, that's particularly a main topic of your Java course, not C course, because inheritance is not in there is no inheritance in C language, right? But this function pointer, okay, maybe I can ask you some question about the function pointer. This function pointer is really nice, right? You are just declaring a variable, but you can point to a function to use later, right? Clear? Any questions so far? Okay, so we can have more example in Union. Okay, so what we're going to do here, like you know that for Union you can save the space, right? How? I will give you one example. Suppose you are designing the structure that will contain the information about an item that's sold through a gift catalog. So whenever you have a gift catalog, there can be like many kind of items, right? Okay. So each item has a stock number, and the price, as well as other information that depends on the type of the item for sure. Suppose on the gift catalog you have books, you have mugs, you have shirts, right? So for the books, these are the attributes. For the mugs, this is the one, and for the shirts, these are the like the attributes, right? So if you want to create a structure with the catalog item, right? So these will be your members, right? Like the stock number, price, item type, then title, author, number of pages. This is for book, right? And the color, size. Okay. So only thing you like the most important thing you need, this is the item type, right? Like what kind of item this is, depending upon that you are going to choose, right? So the item type member would have one of the value, either book, mug, a shirt, right? The colors and size members would store the encoded combination of color. Yes. So this structure wastes space because, so whenever you are having a particular item, you're not going to have this all together, right? Okay. So whenever you are having a particular item, you're going to waste the space for others, right? But if you use a union of structure, then it can be reduced space, because only the widest or largest amount of the member it will just assign in the memory, right? Clear? So what we can do, this is we can use the union of structure now, right? So we can just like separate the variable that is common, right? The stock number, price, and item type. Then we can just organize in a nice way like this. So for the book, we can just declare a structure in the union, right? This is for mug, and this is for the shirt, right? Clear? So you know that whatever the largest like uh, in together, right, these variables, this is just one, these are three. So for sure, maybe for this one will be the largest, so union will just make space for this one. And this is okay because we are not going to access all of them or two of them at the same time. We're just going to use one at a time. So that's why this is another example where it's better if you use the union. Okay. So whatever the function pointer, any questions so far? So there can be more example of function pointer as well. So what we can do, we can also use function pointer as an argument of function. So here you can see that this is a function, right? So this is actually, we are using a function pointer, right? Clear? So this is a function pointer rather than any other kind of value. Okay. So now I just want to make clear that in your lab 1 you use qshort function. You just like run the code to see like how it works, right? But you didn't know like the implementation part, or what is the thing, right? Okay. So this qshort, actually, if you look back to your lab 1 code, this is the prototype, right? And in this prototype, actually we have these, right? This is again a function pointer. So how we can be sure that this is a function pointer or not? For sure that it should be parenthesis include with and a pointer. So by that way you will be sure that this is function pointer, okay, not a pointer. So whenever you see some pointer including the parenthesis, that's a function pointer, right? Here. So I will start the error handling or the exception handling from the next class, that is on Tuesday's class. So also I will upload your assignment number 4 soon, and I will just describe assignment number 4 in our next class. So Andrea, so that function pointer was passed as a parameter for another function. Yes. So it's kind of that like it's not nested function, but inside as a parameter, right? Like this is a function, right? Inside a parameter, you are also using a variable that's actually referred to a function, right? So it's working like that. So this value actually it will come, like suppose this compare you can assign to some function, right? And then whatever the value it returns, it will take that value. So when you would the due, okay, the next assessment due will be, I think your exam period will start from April 13th, right? So you will have around 2 weeks, like April 12th is your due of assessment number 4. Okay, clear? So will you have the office hours today? Yes, for sure. Yeah, from 3 to 4. So I will just offer some slots. You guys can take the appointment from there, from your Learn communication and then Cisco WebEx, and click appointment booking. Okay. So any other question? Okay, so we are going to end today's class here now. Uh, Another question, will the exam involve us sending in photos or scans the pages, or will it be typed? So if I use CrowdMark, so the thing is that this CrowdMark and EMLearn, they're kind of different. So if you have EMLearn, like if I choose EMLearn, you are going to do all the things in kind of the online based, like maybe you can choose the answer in multiple choice question, maybe you have provided the space you have to code, right? That's kind of learn. But for CrowdMark, it's different. Like there are several ways. One way is that you can have your own pen and paper, right? Or what you can do, you will get a question like a PDF, right? You can just print it, then you will just answer it in your own room. And for sure, like I will expect all of you to be fair. If I use CrowdMark or YouMlearn, like you should do it like in your own space. Like maybe I will. Uh, so this is the kind of a disadvantage of online things. Like you guys can have the option of cheating if you have, but if you get caught, like there are several ways in both learn and CrowdMark also. Okay, so that you shouldn't do it together. Like two persons should not be in the same room, right? Or if you, so there are several ways we can detect that. Okay, so better not to discuss that. So that's the thing. So let's get to the part that how we can do it. So the question is there in CrowdMark, you can just print it, you just fill it up within your time or something, and then you capture the images by your phone, you can just upload those. Another way is that you can just scan it and then you get the PDF, upload that. Okay, that's for CrowdMark. Like you need to upload something for CrowdMark, right? For UMLearn, it's just online. All the things are online. Like you have a kind of interface, right? You are just like doing it in all the things online. Like maybe for multiple choice question, you are clicking right there, or for short question, you are just typing your answer. Okay. No, they will not be both. Okay, either I will choose YumLearn or CrowdMark. Thanks for the explanation. It helps clear things up. Okay, you will definitely own be risking cheating and failing for sure. Any other question then? Is there a specific time to the exam? Uh, yes, like if you had previously any kind of online course, like for Learn, the thing is that I can have a time window. Like whenever you will start, you will get that particular 2 hours of time. Okay, but I can give you a time window that you can start between this up to this time. Okay, so it's not like all the students are starting at the same time, not like that. I can give a time window, but whenever you are going to start, your time starts there and it will end like after 2 hours, something like that. For CrowdMark, for YouLearn. For CrowdMark, um, I still have to know the things like how it works, the time things. Maybe whenever you click or download the question, right, the time will start from there. So after 2 hours, maybe it will give you some kind of the time portion that you need to upload now. If you don't, then your exam will not be counted like that. Okay. So so is it clear? Is for the time things, Adrian? Okay. So another student asked, so when will be our last class? This Friday? No, next Monday. So your April 6th is your last day of class for this term, right? So we will have April 5th is our last class. Okay. So maybe it will be short class. I will just review your exam things. Nothing else. Any other question? Braden asks, would it be possible to do the exam at an earlier time or date? Uh, I'm not sure. I have to ask Lean about that. Uh, because the date and time are fixed. So it's on the ROAS also something. So I'm not sure whether we can change that or not. Okay, also you have your assignment for due will be April 12th, right? So and your scheduled exam date is April 25th, right? So let's see if I can do it. I can, but you know that maybe you are okay. Like if I so let's do the exam on the scheduled date. That is better maybe because you know that other students can have other exam on the previous earlier date, right? So then it will be mixed up and then we cannot do it, right? So whatever the date is scheduled, I think we should go for that. Clear? Otherwise it will be mixed up. uh Adrian said, I guess everything will finalize by next week. Yes, for sure. Eric said, what other classes will you be teaching in future semester? I'm not sure because it's the corona things. You know that even for the summer, I think it's just online based. So previously I took 1020 for online course like last summer, but I'm not sure whether I will get it to teach for this one or not. Clear? Okay, any other question? Okay then, so we are ending today's class here. Thank you. Stay safe. I'll see you guys, not see actually, I'll, I will have the next class on next Tuesday. Bye everyone.